Hello students, welcome back. So in this session, I'm going to be talking about hyperparameter tuning. So what exactly is a hyperparameter tuning? Well, in machine learning, there are two types of parameters. There's a model parameter and there's a hyperparameter. So the model parameter, it is learned automatically. These are learned from the data during the training process. In this case, you do not have control over them. For example, the weights in your linear regression, these are calculated from the training data. The coefficients in your logistic regression, those are calculated from your training data. Also the node splits, these in your decision trees, these are done from your training data. You do not set these model parameters manually. These are calculated for you by the machine learning algorithms. So the hyperparameters, they are set by us before the training. So these controls how your model they learn. So for example, the K in KNN, K refers to how many nearest neighbors do you have. For maximum depth in your decision tree. So this refers to how deep your decision tree is going to be. Then you have N estimators in random forest. N estimators in this case refers to how many trees you have in your random forest. And likewise, you have learning rate in gradient boosting. So these are just few examples over here. Now these hyperparameters, they must be chosen carefully. If you pick up a wrong value of a hyperparameter, that would translate to a bad model performance. So hyperparameter tuning means finding the best combination of hyperparameters for maximum model performance. So why do we even need hyperparameter tuning? Well, the answer is because if you have a too simple model, then it's going to underfit. On the other hand, if you have a too complex model, it is going to overfit. So by having a correct hyperparameter, that's going to give you the best generalization. So your goal is to maximize accuracy on unseen data, and that is achieved by using hyperparameter tuning. So there are different types of hyperparameter tuning methods. One of them is a grid search CV. This stands for grid search cross validation. This one is an automated hyperparameter tuning method. And what it does, it tries all possible combination of hyperparameters. It uses, by the way, cross validation. That's what this CV stands for over here. And this way it finds the best performing model for you. And then you have randomized search CV. This one, instead of testing all combination, what it does, it randomly selects some combination and it tests those some combination and see which one gives you the best performance. So one of the pros of this is that it is much faster than grid search. Well, that's because it's not trying all combination. It's just trying some random combinations. It works very well for large parameter space. In other words, if you have a lot of parameters, this is the best alternative. It's able to find almost like near optimal models quickly. Well, that's because it's not trying all combination. Again, it's doing random it's randomly picking up parameters for you. Now, one of the cons is one of the disadvantages is that it does not guarantee optimal result because it's using random search. So randomized search CV, it is best when you have a large data set or you have a deep model or if you have limited computation time.